Hi, Joe. So I'll take you through the ways of doing questions 11 and question 12 using a calculator. You're right that your calculator will make short work of these. Um, my explanations will be fast, will be longer than it would take you to actually do if you knew your calculator. So the other thing to take note, of course, is that it's worth 2 marks. So it's not worth a lot of marks here. So you would want to show a little bit of working out, but not a lot. Um, so when you look at the graph here, so we've got the context here of mountains and sea levels and entrances and exits and stuff like this. But ultimately, if you have a look at it, it's a parabola, which is the mountain, and a tunnel, which goes through the mountain here and here. And so we effectively have a point of intersection kind of problem here. So we're interested in what's the point of intersection here and what's the point of intersection here. And specifically in the context, it says at what heights above sea level. So we're not interested in the x coordinates, just the y coordinates here and here. So a couple of ways of doing it on your calculator. Oh, if it was the non-calculator section, by the way, you would simply set this part of the equation equal to this part of this equation, simplify it down to a single quadratic and then solve for x, and then substitute your values in from x to work out y, the two y values. That's how you do it. But yeah, your GDC will do it a lot faster. So let's see how we go. First way I'll show you is by using your graphing part of your calculator. So I've added a graph to this document, and I'll type in the first one. So I'll just add a fraction, and I'll put minus x squared in here, and then I'll put, what is it, 2, and then plus 5, using my arrow key to get over to the other side. So there's the first one. Beautiful. And then I'll add a new graph, so Control G to add a new graph, and I'll put in my fraction again. And I'll have x over 4. I'm going to be faster. I probably could have typed in 0.25x instead of x over 4 plus 2. And there we go. That looks pretty much the same as what the graph is on the left-hand side here. So then I can use your old pal menu, analyze graph, and then the option we want here is intersection, and that will get us our answers with some limitations, which I'll talk about in a second. So I'll click on this. The first thing it says is to select a lower bound. So I use my arrow keys to go to the left-hand side of the point of intersection, doesn't matter where. Close is probably reasonable though. And then click. So single click, click, and now it's asking for an upper bound down here. See, it said lower bound, now it's saying upper bound. And I'm going to drag my area off to the right here, and you can see in faint grey there, it says negative 2.71 and 1.32. So because we're looking just for the height, the only thing we're interested in is the 1.32, and that's good enough. And if I keep on moving my cursor across to the other point of intersection, just beyond it, it'll eventually jump over, and you can see it now says 2.55. So we've got 2.55 and 1.32. So we write them down as we go along, and our job is done. But if we want to keep a permanent record because we're doing something else or because we just want to see them on the screens before we forget, if you drag over to the other side and click, it'll now turn it into a coordinate that you can move out of the way like this. And then you can do the same thing again. So menu, analyze graph, intersection. So menu 6.4, click to the left, click to the right. And there is the second one permanently lodged there, 1.32 and 2.55. So there you go. You can write those down, and I reckon because it's worth 2 marks, it's pretty well much a mark for each of them, I would say. But here I'd probably say points of intersection are by GDC, negative 2.7, 1.32, 2.2 and 2.55, and then you could write that down. Okay, limitations are, it's only 2 decimal places that you can see here. The second limitation is that unlikely for a contextual question like this, but it could say, what are the exact heights? And if it's exact heights, then we can't use our decimals here. So I'm going to show you a different way of getting these two values out. It's a little bit more involved, and I wouldn't do it unless I needed more decimal places or if I needed an exact value. So I'll just add a new page, and I'm going to add a calculator this time. And if I go to menu and then down to algebra, so menu 3, and then we're looking at 7 for solve a system of equations. And then I want the first one here. The second one's really useful if you've got linear equations, like that means x to the power of 1 are all the equations, but we've got an x squared here, so we need to use this one. How many equations? We've got 2. How many variables? X and Y. Click on OK. And then in each of these boxes here, we're going to put each of these equations here, exactly like we did before. So here I'm going to go Y equals, and then I'm going to type in my, my fraction. So minus x squared, and then down here, over 2. Again, I could have gone 0.5 minus x squared, and then I'm going to use my arrow key, and it'll get me a big red line like that. So I'm putting my plus 5 in like so. So here's my first equation, and then click into this box, or use your arrow keys to get down to the next box. Y equals x on 4. I'm going to do it this time, 0.25 x plus 2. So there's my equation 1. There's my equation 2 from here. Press return or enter. And there's my approximate values there. Oh, do you know what's giving me approximate? Because I've used 0.25 here. So you've got x equals minus 2, 0.7, and heaps more decimal places, and y equals 1.3219. So you can have more decimal places. So you might say, if these are kilometers, you might need 3 decimal places, so 1.322. And use a little arrow key, your arrow key, to move on to the next one, like so. 2.553, etc., etc., etc. Okay, so that's one way of doing it. I'll just for the sake of it, I'll just launch this again. Hang on, sorry. I'll just launch this again. And, oops, come on. For some reason it's not working for me, so I'll just copy and paste it. I'll just put this back to x on 4. Y equals x over 4, just to show you that what you get is the exact values when you've used fraction notation instead of decimals there. So if you needed an exact value, there it is there. Okay, that's question 11 done. You'd write those 2 answers down. Contextually, I would definitely just be using decimals, and I would definitely just be using these points of intersection. I think that'd be the fastest way of doing it, but I just wanted to show you there are different ways of getting it if you need to. Question 12. Again, because it doesn't say anywhere exact point, I'm not going to even bother trying to do exact values here. I'm going to use approximations as I go along. So let me fire up a brand new page. I'm going to add a graph, of course, and I'm going to type in x cubed minus 7x squared minus 7x squared plus 4x plus 12. That's the graph. I'm going to zoom out a little bit. Let me see now. I'm just going to do it by guessing, I think. So I'm going to go menu, window zoom, window setting. I'm going to say minus 5 to, I can't see it now, to 5, but I'll make this minus 20 to 20. Oops, that was a bit too, that was good almost, but go back again. I think it's worth doing it this way, even though you could just use the zoom function. I think it just ends up making the graph better. So I'll leave it at minus 10 to 10, and I'll make it minus 30 by the looks of it to 20. There we go. That looks pretty good. So we've got all these values happening here. The critical thing here is it says indicating all intercepts, turning points, and end points. Use your calculator to assist. Okay, so you could basically draw this in, except you just need to take into account that there are endpoints that you need to put in. So here we go. Now, I paused the video for a second because I was just trying to figure something out. So apologies if what I'm saying is not quite what I was said a moment ago. But what I think I was saying was that you need to do all intercepts, but it's the endpoints that's the critical thing. So I'll show you how to work out the intercepts in a minute. Turning points and endpoints as well is where we're going to focus on. Turning points, you never have to calculate them in the function section. There is a place for calculating turning points of cubics, and that's when we do calculus. So you only can really get them from your graphics display calculator. And I'll show you a fairly simple way of working out the endpoints as well. But what I thought I might quickly show you though is how we can, I haven't shown the class this, it's not super critical, but it is kind of useful, how we can restrict our graph on our graphics display calculator to the endpoints. And I guess I should just point out that I know this has endpoints because it's because of this statement here. For the domain x, an element of, a member of, x comes from the set of numbers from -7 to 7, where -1 is inclusive because there's a square bracket, and 7 is not included because there is a round bracket. Now, these are effectively the endpoints. So you're given the x coordinates of the endpoints, you need to work out the y coordinates of the endpoints. But I'll just really quickly show you this. Here's my function, which I will show you on the screen by going Control G. That gets me to a brand new function. But if I press the up button, there's the function that I've already typed in. And I'm going to add a little bit more to it. So I'm going to go Control equals, and I'm going to use this vertical bar, which is short for such that. So here is a function defined by this rule here, such that x is, let me see now, it can be -1 or beyond -1. So that's greater than or equal to. So I go Control equals, and I use my greater than or equal to sign, and then I put the value -1 in. And then I just type in the word and, A-N-D. So I'll put a space actually first. So space, and, I don't know if the space is necessary, but I'm doing it anyway. And, see how it turned from italics to not italics? That tells me that that's the right word, space. And then I go there again, x, and this time I need to tell it that x has to be less than 7. Not less than or equal to, but less than, because there's a round bracket on this side. So Control equals, less than, and then type in 7 and press enter. And you can see now that my graph stops there at x equals -1. And it goes, it's going beyond the screen. I suspect that's because I need to zoom out more. So let me do that. Menu, window, settings, maybe go to 30. Ah, damn it. I should have just gone a bit more broad. Hang on a sec. Sorry, a bit of an interruption there. This is what I get for doing it at home. Where was I? Yeah, so I'm just going to zoom out a little bit more again. Make it 40. I should have made it 50. I was thinking in my head I should have just gone straight for 50. Make it 50. There we go. So now, I guess the benefit of that is you can now graph it exactly how it should do. You know, it goes all the way up here, and you know it's going to be between 40 and 50, right? Because I don't know what it is yet, but I will figure it out in a second. So there's your graph, and it does say it does not need to be scale, but you can pretty much just draw your curve in exactly as it needs to be. But we do need to indicate all intercepts, turning points, etc. So let's use what we can in the GDC to get the information that it asks for. So I'm going to use Analyze Graph, and I'm going to use zeros first. And again, I can click to the left and click to the right and click again, and that'll nail that x-intercept in place, -1, 0. Or I can just write it down on my graph and then keep on moving this over, and it will keep on flicking. So we've got 2. Keep on going. It's not going. Yeah, and then 6. So there we go. -1, 2, and 6 would be my 3 x-intercepts, which are what zeros are. Or you can, I do it for all 3, or you can go click to the left, click to the right, and then you've got your point there permanently. And you just do that 3 times over for each of the intercepts here. For the turning points themselves, you need to go Analyze Graph and Minimum or Maximum. So you click on Minimum, and I can go to the left here and to the right here. Oops, sorry, I said minimum, didn't I? Dear me. I'll go all the way to here. And there it is, 4.36, 20.7. And you can see the dots there, so that's definitely the minimum. It's the lowest point of the graph. So you can type right in that turning point, and then I'll go maximum, Analyze Graph. oops, sorry, analyze graph, maximum, go left and right of the maximum here, the dots here, 0.306, 12.6 can be written in. And then we've got our endpoints. Luckily, this one's already written in for us, -1, 0. So I just have to work out what this endpoint is here. I tell you what I could do though. Well, I'll just show you. Menu, analyze graph. I'm going to go for maximum again, because maximum simply means for this domain that I'm selecting, what is the highest value across that domain. It's just that when we choose it over the left and right of a turning point, the turning point would have to be the maximum. But if I do it over here, click and click, there we go. The maximum is also the endpoint, 7,40. And then if I wanted to, I could use minimum here and here to get the endpoint here. I don't need to because I've already got it because it's also a 0, but I could do. Now, in terms of drawing this, you need to do a solid or a filled in circle here because it's an endpoint that's included. And here you graph it as 7,40 and have an open circle here because it says bracket 7, round bracket 7. Okay, so 7, it's up to 7, but not including 7, so it's an open circle. The only thing we're missing is the y-intercept, which is just in there. I can't think of a better way to do it other than using a graph trace. So if I go to menu, trace, and then graph trace, and then use my arrow keys, it will snap onto a y-intercept like so. And the point is down here, 0, 12. But you know what? I didn't really need my calculator for that, did I? Because if you look at the form of the function here, this is going to be the y-intercept. So I didn't really need the calculator for that. I could have just gone 0, 12 because of this. So you would draw that in. There's 1 point, 2 points, 3 points, 4 points, 5 points, 6 points that you would have to fill in on your graph. And that's job done. Hope that's enough to get you going. Sorry it's a long video, but there's a fair bit to cover in that. Let me know if you've got any questions that come from it.